High in Earth's atmosphere, it's far below 32 degrees. And as every child on Earth is taught, water freezes at 32 degrees. Except that it doesn't.
It wants to freeze because it's below the freezing point, but it can't. It needs an impurity around which ice crystals can form, and then a solid can take place.
And this planet's atmosphere is full of tiny impurities that play this vital role.
The particulates that we find in the atmosphere come from many different places. From sea spray, from the ocean, from forest fires and the smoke that they produce. And even here in Death Valley, in a sandstorm, it's going to pick this sand up, toss it into the air, and carry it into the clouds.
And some rain-making particles actually zoom in from outer space. Every day, 6,000 pounds of tiny micrometeorites crash into Earth's atmosphere.
It's hard to believe, but it's estimated that the Earth may get heavier by perhaps 10,000 tons or so every year because it's sweeping through this dust cloud of tiny micrometeorites.
They're very tiny. A micrometeorite is less than the width of a piece of human hair. And what that means is that there's not that much friction as they're falling, so they don't burn up in the atmosphere like a big meteorite would.
This micrometeorite, once part of the tail of an ancient comet, hits the atmosphere. It slows down and eventually drifts into a cloud full of microdroplets. They're below freezing, but they can't crystallize without coming into contact with an impurity like this tiny space invader.
They encounter one of these particles in the atmosphere and crystallize around a single particle.
This happens billions of times a day. And the proof is everywhere on Earth.
You can actually look for micrometeorites yourself. All you want to do is collect some rainwater and get yourself a really strong magnet. You take your magnet and just swish it around in the water for a couple minutes to make sure you pick up everything that's in there. If you look through them under a microscope, anything that's really spherical, there's a good chance that it's actually a micrometeorite.
Now that a water droplet has turned into an ice crystal around the micrometeorite, the crystal itself creates an even larger solid surface for other tiny droplets to freeze onto as well.
But turns out ice is the best template for ice. So once you initiate freezing, you can very readily form many, many crystals from that template.
The tiny crystal grows into a snowflake, heavy enough to begin to fall. But its journey is far from over.
The closer it gets to the surface, the warmer the temperatures, and as it passes through that warm air works to add energy to that ice crystal.
The snow begins to melt and turns into rain.
Here in Vancouver, it finally reaches the ground.
So on a rainy day like today, if you reach out to catch a raindrop, you might actually catch a little micrometeorite.
But take a close look at that raindrop. There might be something else inside. Instead of being formed by a tiny speck of sand or micrometeorite, it might have been formed by a living being. If so, that would hardly be the strangest kind of rain to fall on the planet Earth.